We're going to go to the example for Gay-Lussac's law. So what we have here is we have two containers. These containers are filled with air, and so this one I'm gonna put a moon, draw a moon above that one. So that one's at night. This one's gonna be during the day. So I'll put a sun in front of that one. And so what's gonna happen is at nighttime, the temperature inside the container is 62 degrees Fahrenheit. And in the daytime, it gets hotter. The temperature inside the container is going to be 90 degrees Fahrenheit. The pressure, we have a gauge on this, and so the pressure inside this at nighttime, it's 62 degrees, is going to be 120 pounds per square inch. And then we do not know what the pressure is when it's going to be 90 degrees. And so what we're doing is seeing what effect the temperature has in relationship to what the pressure output is going to be filling on that tank. So if we look at our formula sheet, our law here, the pressure of 1 divided by the temperature of 1 is equal to the pressure of 2 divided by the temperature of 2. And so the first thing that we're going to have to do is convert our pressures to absolute pressure. So absolute pressure is going to be gauge pressure. We know this from our formula sheet. The pressure of 1 is the gauge pressure, 120 pounds per square inch, plus atmospheric pressure, the pressure of our atmosphere, 14.7 pounds per square inch. We get an answer of 134.7 pounds per square inch. Alright, the next thing we're going to have to do is convert our temperatures into absolute temperature, degrees Rankine. So I'll go ahead and write that. So temperature 1 is equal to 62 degrees Fahrenheit plus 460, the conversion to Rankine. So we get a absolute temperature for T1 of 522 degrees Rankine. Temperature 2 is equal to 90 degrees Fahrenheit plus the conversion, 460 degrees, which gives us a temperature 2 of 550 degrees Rankine. Alright, now we can go ahead and use our formula and solve. And so our formula is the pressure from our formula sheet of 1 divided by the temperature of 1 is equal to the pressure of condition 2 divided by the temperature of condition 2. The pressure of 1 was 120. So let's go ahead and we can fill in this stuff. 120 pound, or excuse me, 137.4. So we need absolute pressure. 137.4 pounds per inch squared divided by the temperature of 1, The absolute temperature was 522 degrees Rankine. That has to be equal to the pressure of 2, which we don't know, divided by the temperature of 2, which is 550 degrees Rankine. So we rearrange our formula. Pressure of 2 is equal to 137.4 pounds per square inch times 550 degrees Rankine divided by 522 degrees Rankine. So we'll do that on our calculator. We'll put in 137.4 times 550 and divide that by 522, and we get 144.7 So we divide it out and we get the pressure of 2, or degrees Rankine cancel out, of 141.9 pounds per inch squared. Let's go ahead and write that over here. Pressure 2 was 141.9 pounds per inch squared.